Hello, today we're going to talk about radical operations or roots. Let's start off with talking about some squares, some exponents. 3 squared is the same thing as saying 3 times 3, which is equal to 9. When I take the square root, I'm basically doing the opposite of squaring something. I'm asking myself, what two numbers multiply to get 9? Well, 3 times 3 is equal to 9. So I know that the square root of 9 is 3. But is that all that will multiply to get to 9? What if I multiplied negative 3 times negative 3? Well, we already know that a negative times a negative is a positive, and 3 times 3 is 9. So I don't know if, when I take the square root of 9, if I'm talking about 3 times 3, or if I'm talking about negative 3 times negative 3. So my answer will be 3 or negative 3. Now for 3 cubed, I know that's 3 times 3 times 3. So the cube root of 27, I need 3 numbers that can multiply to give you 27. Well, 3 times 3 times 3 is 27. So I know the cube root of 27 is 3. Now, can I say negative 3 here? Let's check it. Negative 3 times negative 3 times negative 3. Well, a negative times a negative times a negative is, in fact, a negative 27. So I know for the cubed root of 27, my answer is only 3. For the square root of 9, my answer is 3 or negative 3. Now let's try negative numbers. The square root of negative 9. Well, what two numbers multiply to negative 9? I can have negative 3 times a positive 3, or I can have a positive 3 times a negative 3. They both will give me negative 9. But here's the question. Are they the same number? No, they're not the same number, which means that there is no real solution to the square root of negative 9. Later on, we'll learn that you can have an imaginary solution, and we call that 3i. But that's not going to be the focus of today's lesson. Now, if I take the cubed root of negative 27, we already said that negative 27 can be found by multiplying 3 negative 3's. Since all 3 are the same, that is going to be my answer, negative 3. To make your life easier, you should have a perfect square list. In fact, you should have most of these memorized already. 620. Now, let's take those perfect squares that we just went over and do the opposite. Let's take the square root of them. So 64, the square root of 64 is 8, because I know that 8 times 8 is 64. So I would say 8. But I also know that negative 8 times negative 8 is 64. And since this is a positive in here, I don't know which it was. So I can say 8 or negative 8. Some people will say plus or minus 8. Square root of 25, well, 5 times 5 is 25, so plus or minus 5. The square root of 1 over 36. Now this one I can treat them as individuals. What is the square root of 1? Square root of 1 is 1. What is the square root of 36? 6, plus or minus. The square root of 81, 9 of course. The square root of 121, 11. Now some of you will say, but 9 is still a square root. Can I do it again? The answer is no, you can't do it again. I've already used the square root sign on the 81. I can't keep using it over and over. Think of putting money into a vending machine. Once you put the dollar in, you get your soda. You can't keep putting the same dollar in over and over again. You've used it. What if they're not perfect squares? Then you need to simplify. Use the primary tree. So you've already seen me break the numbers up, so keep doing that. I know 24 can be broken up into multiple things. I'm going to start easy. 2 and 12. 12 breaks into 2 and 6. 6 breaks into 2 times 3. Now since it's a square root, that means I need 2 of the same number to come out. I always circle my pairs. I have a pair of 2's that come out. So they come out of the house. Think of the buddy system. When you're in elementary school, you need a buddy while you're on a field trip in order to explore. Here, you have to have a buddy in order to get out of your house also. The 2 has a buddy, so he comes out of the house. The second 2 and the 3, since they are different numbers, they don't have a matching buddy. So they have to go back inside the house. When they go back inside the house, they multiply. 2 times 3. So that gives you 2, the square root of 6, plus or minus. Next, I have a 3 already outside the house. So I'm going to go ahead and write him outside the house. And we'll come back to him. Right now, the square root of 50. 50 has a 0 at the end, so I know that breaks into 10 and 5. 10 breaks up into 2 and 5. The 5s can come out of the house because they have a buddy. So I write the 5 outside the house. The 2 does not have a buddy, so he needs to stay inside the house. Now, outside we also have the 3. When two numbers are outside the house, they simply multiply. 3 times 5 is 15. That will give me 15 square root of 2. Next, 180. That's a big number, but I know that because there's a 0 there, I can take out a 10. That's going to break into 18 and 10. Well, 10 breaks into 2 and 5. 18 breaks up into 9 times 2. 9 can break into 3 times 3. I have a pair of 3s that need to come out. I have a pair of 2s that need to come out. And then the 5 is all by himself in the house. So I have a 3 that came out, I have a 2 that came out, and the 5 is left inside. Well, 3 times 2 is 6, and the square root of 5 is left inside. Now let's explore some vocabulary, the parts of the radical. Obviously, the radical sign itself, which I call the house. Then there's the index. The index is the number inside the crux of the house. Up till now, we've talked about square roots, where it's invisible too. However, if it's not a square root, then we have to put a number there. A cubed root means you need 3 things. The fourth root means you need 4. The number that's inside the house is called the radicand. Now, we have the cubed root of 32. The 3 is the index, the 32 is the radicand. 32 can break up into 2 times 16. 16 can break up into 2 times 8. 8 can break up into 2 times 4. And 4 can break into 2 times 2. Now, I'm not going to circle pairs. I'm going to circle groups of 3 because my index told me I need 3. I have 1, 2, 3 2s. But then I only have 2 individual 2s there. So the group of 3 comes out as a single 2. And then I had 2 times 2 left inside. So that gives me 2 cubed roots of 4. Now I have 7 cubed root of 54. Again, the 7's already outside, so I'm just going to move him over. The 54 can break into 2 times 27. Well, 27 breaks into 3 times 9, and 9 breaks into 3 times 3. I take the group of 3s. They get to come out of the house, so I write them out of the house. And I still have a cubed root of 2 left over. Since both the 7 and the 3 are outside the house, they get to multiply. 21 cubed root of 2. On the far right here, I have the fourth root of 16. That means I need 4 of the same number. Well, 16 breaks into 4 times 4. Each 4 can break into 2 times 2. That means I have 4 2s. Well, that's what I needed. My index told me I needed 4 of something. So the fourth root of 16 is simply 2. Now that we have different indexes or indices, we need to see what the difference is. We have odd versus even. Remember odd, 1, 3, 5, 7, and even 2, 4, 6, 8. If it has an odd index, it has one real root. That's why we said the cubed root of 27 is equal to 3. Now, if it's an even index and a positive radicand, a positive number inside, we have 2 real roots. That's why we said that the square root of 9 was plus or minus 3. That gave me 2 answers, 3 or negative 3. Then if it's an even, a square root, and a negative inside, that means we have no real roots. So if I try to take the square root of negative 16, I can't. There's no real solution. The square root of 9 is positive or negative 3. The square root of negative 9 is no solution. The cubed root of 8 gives you 3 positive 2s. Your answer is positive 2. The cubed root of negative 8, 3 negative 2s. So your answer is negative 2. Fourth root of 16, plus or minus 2. The fourth root of a negative No solution. The fifth root of 32 gives you 5 2s, so your answer is 2. And the fifth root of negative 32 gives you 5 negative 2s, so your answer is negative 2. Simplifying the radicals. Treat the radicals as if they're a set of parentheses. So if I'm following my order of operations, I need to do what's inside the parentheses first. So here inside the parentheses, I have a 3 squared and a 4 squared. I rewrite the parentheses and I do what's inside. 3 squared is 9 plus 4 squared is 16. Well, 9 plus 16 is 25. Square root of 25 is plus or minus 5. Moving to the right, 15 squared, that was part of the squares that we should have memorized, 225. Negative 4 times 3 is negative 12. Negative 12 times 12 is negative 144. It says subtraction, so 225 minus 144 is 81. Well, the square root of 81 is simply plus or minus 9. Moving down to the bottom left, we have square root of 6 squared, 36. Negative 4 times 2 is negative 8 times 3, negative 24. So negative 24. Well, 36 minus 24 is 12, square root of 12. That's not a perfect square, so what I need to do is simplify it. 12 breaks up into 2 and 6. 6 breaks up into 2 times 3. I have a pair of 2's that comes out with a 3 left over. That gives me 2 square root of 3. 12 squared is 144. Negative 4 times 2 is negative 8. Negative 8 times 18 is negative 144. Well, 144 minus 144 is the square root of 0. The square root of 0 is simply 0. Now, there is no plus or minus 0. It's only 0. Now, if you have fractions like this, there's two ways of doing it. If they're perfect squares, simply take the square root. If they're not perfect squares, then see if you can simplify them first. For example, 2 divided by 72. Can I reduce that? Yes. I can divide the top by 2, and I can divide the bottom by 2. That gives me the square root, it's a big house there, 1 over 36. Now can I take the square root? Square root of 1 is 1, and the square root of 36 is 6. So I have plus or minus 1/6. The number on the right, however, is a little different. I know 9 is a perfect square, I know 36 is a perfect square, so I can take the square roots of both of them. That would simply give me 3 over 4 and a positive or negative. On the bottom left, 18 is not a perfect square, and neither is 2. However, there's two different houses. Don't worry about it. Simply change them to one big house. That would give you 18 divided by 2. Well, what is 18 divided by 2? We know that is 9. Well, the square root of 9 is equal to plus or minus 3. The one on the right is asking for the cubed root. And again, there's two separate houses. Simply combine them into one large house. That gives you the cubed root of 32 divided by 4. Well, 32 divided by 4 is 8, so I have the cubed root of 8, which is simply 2. Now, if we're going to add and subtract radical expressions, you can only add or subtract like terms. Well, what are like terms? Like terms have the same index and the same radicand. Those are the only ones that you can combine. Well, what can you combine if those are the same? You only combine the number in front. We call that the coefficient, the number in front of the variable. So if I look at the top left problem, 3 square root of 5 minus 6 square root of 5. The coefficients are 3 and 6. Meanwhile, both of the other numbers have the same radicand and the same index. They're both the square roots, and they're both a 5. So I can subtract these. That's going to give me 3 take away 6 is 3. 6 is a larger number, so he keeps his negative sign. And the square root of 5 is still at the end. We don't change the square root of 5 at all. If I look at the number on the right, again, I have like terms. They're both the square root of 3. However, I only see one coefficient. I only see the 4. Whenever you have a problem like this, write in the missing coefficient. If there's nothing there, it's an invisible 1. So write it out. Now I can see I have two coefficients. I have 1 and 4. Well, 1 plus 4 is 5, with the square root of 3 hanging off the back. Sometimes they look different, so I need to simplify them first. Square root of 24 can be simplified into 2 times 12. 12 breaks into 2 times 6, and 6 breaks up into 2 times 3. I have a pair of 2's that can come out, so I'm going to rewrite this equation. 2 came out with the square root of 2 times 3, which is 6, left inside, plus the square root of 6. Well, what is the coefficient on the second number? The coefficient on the second number is that invisible 1. So now I have like terms, the square root of 6 and the square root of 6. 2 plus 1 is equal to 3 with the square root of 6. And again, on the right, we're going to try to break it up and see what we get. 27 breaks into 9 times 3, and 3 breaks into 3 times 3. 15 breaks up into 3 times 5. I take out this 3, and that leaves me with a 3 already in front times the other 3, square root of the 3 that's left over, plus 6 square root of 15. 3 times 3 is 9 square root of 3 plus 6 square root of 15. Since there are no like terms, I cannot add or subtract anything. I did simplify my radical, so I am finished. If you hadn't simplified your radical, you would not be finished and would have gotten the problem after all. Let's try one more that's a little bit bigger. 125. Well, that breaks up into 5 25s. And 25 breaks into 5 times 5. 27. We just did this. 3, 9, 3, 3. 45 breaks into 9 times 5, which breaks up into 3 times 3. And 12 is 2 times 6, which breaks up into 2 times 3. So let's take everything out that we can. I have a pair of 5's and a 5 left over. That leaves me with 5 square root of 5. Plus, I have a pair of 3's, but don't forget your original 5. 5 times 3 is 15, because it was 5 times 3, with the square root of the 3 minus, don't forget to bring down your negative sign, I have a pair of 3's that can come outside, and a 5 left over. And last but not least, I have a set of 2's that can come out, and a 3 left over. So now you look for your like terms. I have the square root of 5, and then I have another square root of 5. So these are my like terms. Then I have a square root of 3, and I have another square root of 3. So again, these are like terms. I can combine like terms only. We'll start with the square root of 5's. 5 square root of 5, take away 3 square root of 5, leaves me with 2 square root of 5's. 15 square root of 3 plus 2 square root of 3 leaves me with a positive 17 square root of 3. And since these are not like terms, I cannot combine them, and this is my answer. Multiplying radical expressions. When multiplying radicals, multiply the inside times the inside and the outside times the outside. Straightforward, no tricks. The 3 is outside, he multiplies times the 4. The 5 is inside, he multiplies times the 6. That gives me 3 times 4 is 12, 5 times 6 is 30. Always look to see if you can simplify. I know that 30 breaks up into 5 times 6, so there's nothing I can simplify, and we're finished. Do it again. 5 times 7, 6 times 2, 35 square root of 12. Well, can I simplify the 12? 2 times 6, we just did that. And then 2 times 3. I have a pair of 2's that can come out. I already have the 35 in front. So 35 times 2 is equal to 70. I have 70 square root of 3. Moving on, I have the cubed root of 9 and the cubed root of 6. Well, I can't get rid of the 9 because it's a cubed root and not a square root. So I'm simply going to have to multiply them. Outside times outside and inside times inside. Now, what is the outside of the second number? Well, it's the invisible 1. Make sure you always write your invisible ones. 2 times 1 is equal to 2. Cubed root 9 times 6 is 54. Now I need to see if I can simplify these. 54, we just said, is 9 times 6. 9 breaks up into 3 times 3, and 6 breaks up into 3 times 2. So I have a set of 3's that can come out. I need 3 3's because it's a cubed root. So 2 times 3 is equal to 6, which gives me 6 cubed root of 2. Next, I have the cubed root of 45 times the cubed root of 81. Well, those are big numbers, and I don't want to spend the time to multiply them out. So I want to see if I can shrink these numbers. I know that in the end, I'm going to have some very large number that I'm going to break up into 2 pieces. So I'm going to start by breaking them up. Do I know what that number is? Don't know. Don't really care, because I'm going to break them up into 45 and 81. Well, 45 breaks up into 5 times 9. 9 breaks into 3 times 3. 81 breaks into 9 times 9. 9 is 3 times 3, and 3 times 3. So let's see if I can take anything out. This is a cubed root, so I need 3 of the same number. I have one set of 3 right here, and I have another set of 3 right there. I have 2 sets of 3 that I can take out. So that means I'm going to take out 3 times 3 is 9. I have a cubed root of 5 left over. And that is my answer. So if you have large numbers and you know in the end they're probably going to simplify, we don't need to spend time to multiply those numbers out because instantly we're going to break them up anyhow. So simply start by breaking them up. You can never, ever, ever have a radical in the denominator. You can never do that. So what do? Instead? We rationalize the fraction. Basically, we get the radical out of the denominator. You do this by multiplying the denominator by another radical so they can cancel out. And remember, with fractions, whatever you do to the bottom, always do to the top. But before we get there, let's take a look. If I said, what is the square root of 2 times the square root of 2? You would tell me, well, that's the square root of 4. Well, what is the square root of 4? It's simply plus or minus 2. Again, square root of 5 times square root of 5. That's equal to the square root of 25. Well, square root of 25 is simply 5. So what we're seeing here is that if you multiply a radical times itself, it's going to cancel out and simply give you the number that was inside. Well, what if I have a cube, though? Well, the cubed root of 9 times the cubed root of 3 is the cubed root of 27. Now, we've done 27 a few times, so we know that the cubed root of 27 is 3. Well, how did I figure that one out? 9 has 2 3's. So in order to get the 3 to come out of that house, I needed 3 3's because it told me a cubed root. Now let's move on to some fractions. I have the square root of 2 on the bottom. I need to get rid of the square root of 2. We saw up above that if I multiply a square root of 2 times another square root of 2, that they'll eventually cancel out because that will give me the square root of 4, and that will simply give me 2. Now whatever I do to the bottom, I have to do to the top. Square root of 2. That's going to equal square root of 7 times 2 is 14 over the square root of 4, which gives me the square root of 14 over 2. I can't simplify the square root of 14, so I am finished. I rationalized the denominator. If I look at the square root of 6, well, in order to get rid of the square root of 6, I'm going to multiply by another square root of 6. I simply multiply by the same thing. Why does that work? Because that gives me the square root of 36 on the bottom, which will give me a 6 on the bottom. Now, whatever I do to the bottom, I have to do to the top, times square root of 6. Well, that gives me the square root of 60. Can that be simplified? Off to the side, I'm going to write a 60 and then break it apart. I know that's 10 times 6, because we just did that. 10 breaks up into 5 times 2, and 6 breaks up into 2 times 3. I have a pair of 2's that can come out. That's going to give me 2 on the outside. square root of 15 on the inside. Now the 2 and the 6 are both outside. I need to look to see if I can simplify those. And I sure can. They're both even numbers. So I'm going to reduce the top and the bottom by 2. That's going to give me 2 becomes a 1, 6 becomes a 3, square root of 15 over 3. I don't have to write the invisible 1. Now, we did not do that on the first problem because the 14 is inside the house, the 2 is outside the house. I can't multiply or divide if one is inside and one is outside. However, on the right-hand side, they were both outside the house, so I was able to simplify those, giving me the square root of 15 over 3. Let's look at a few more. I have the square root of 3 on the bottom, so I'm going to multiply by the square root of 3. I don't need to multiply by the 5 because the 5 is perfectly fine down there. I simply need to get rid of that radical, and the only thing in the radical is the 3. Whatever I do to the bottom, I also do to the top, times the square root of 3. That gives me 2 square root of 24 on the top, and on the bottom, well, I know that square root of 3 times square root of 3 is the square root of 9. The square root of 9 is simply 3. That's why we're doing this. That gives me 5 times 3, which is 15. Before I continue, I need to see, can I simplify the 24? So 24 breaks into 3 times 8. 8 breaks up into 2 times 4, and 4 breaks up into 2 times 2. I have one set of 2's that can come out. There's already a 2 there, so 2 times 2 is equal to 4. I have 4 square root of, and who's left inside? 2 times 3 is 6. 4 and 15 cannot reduce. I am finished. Look on the right. Do I need to multiply the square root of 4 times another square root of 4? No. I know the square root of 4 is simply 2. I know the square root of 16 is simply 4. That's going to give me 5 times 4 because I took the square root. That's going to give me 2 times 2 because, again, I simply took the square root. Before I multiply these, I can reduce. 4 can become a 2 and cancel out. This 2 can become a 1 and cancel out the other 2, which gives me an answer of 5. Remember, always give your answer in simplest form. Moving on to cubes. We said earlier that I need 3 of the same number in order to get a cube. So if I'm going to cancel out the 2, how many 2's do I need? I need 1, 2, 3 2's total in order to cancel out the 2's. How many 2's do I have? I only have 1 down there. So I need to multiply times the cubed root of, I need 2 more, 2 times 2. Whatever I do to the bottom, I do the top, times the cubed root of 2 times 2. Why did we do that? Now I have 1, 2, 3 2's, which is the cubed root of 8, which is simply 2. That's going to give me the 2 on the bottom, and 2 times 2 is 4, times 5 is 20. Cube root of 20 on top. Let's do that one more time. I have the cubed root of 9. Again, I need 3 to get out. I only have 1 9. Or we can say I have 2 3's. I need 3 3's in order to break out the cube. So I'm going to have to multiply it by 1 more cube root of 3. Whatever I do to the bottom, I do the top. Cube root of 3. That means on the bottom I have 1, 2, 3 3's. The cube root of 3 3's is simply 3. On top, I have the cube root of 45 times 3. Now that's a big number. I don't want to find out. I know I'm going to have to break this up anyways. So I have a number that's going to break up into 45 times 3. Well, 45 breaks up into 5 times 9, and 9 breaks up into 3 times 3. I have a set of 3 3's with a 5 left over. That gives me 3 cube root of 5 over the 3 that was already there. Now, can I reduce? Of course I can. I have a 3 on the outside, and I have a 3 on the outside. 3 divided by 3 is 1, which gives me a final answer of cube root of 5. We'll run through 2 more examples really fast. I have a cube root of 2. How many do I need? I need 3 2's. How many do I have? I have 1. I have 1 2. I need 1, 2 more to go. So that means I'm going to have to multiply the bottom by the cubed root of 2 times 2. Whatever I do to the bottom, I do to the top times the cubed root of 2 times 2. On the top, it's simple. 8 times the cubed root of 2 times 2 is 4. On the bottom, cubed root of 3 2's is equal to 2. So that leaves me with 5 times 2 on the bottom. Now, before I multiply 5 and 2, can I reduce top to bottom? Yes, I can. I cannot touch the 4 and the 2 because the 4 is inside. However, I can reduce the 8 and the 2. 8 divided by 2 is 4. The 2 becomes a 1. The 8 becomes a 4. That leaves me with 4 cubed root of 4 divided by 5. The one on the right, I have the square root of 3. Well, square root, how many do you need? You only need 2 of the same thing. So I need to multiply this times another 3. What I do to the bottom, I do to the top, times 3. Well, the square root of 3 times the square root of 3 is the square root of 9. The square root of 9 is simply 3. So on the bottom, I have 5 times 3. On the top, I have 21 times the square root of 3. Before I multiply 5 times 3, I look, can I reduce? I can only reduce the 21 and the 3. I cannot reduce the 3's because he's outside the house and he's inside the house. 3 divided by 3 is 1. 21 divided by 3 is 7. That leaves me with 7 square root of 3 divided by 5.